Alright, silly people, here's the situation. We have a distribution of ages of a group of 14 people. One of them is aged 14, one of them is aged 15, 3 or 16, 2 or 22, 2 or 24, 5 or 25. And we're meant to find the expectation value of the ages, as well as the expectation value of the squared ages, the squared expectation value of the ages, the standard deviation in two different formulations, and also the variation for each one. All right, so first, let's just do the expectation value of j, which will be given by the formula sum of j times n of j over n, where n will be 14. So it's not too bad. That's just going to be, we have 14 times 1 plus 15 times 1 plus 16 times 3 plus 22 times 2 plus 24 times 2 plus 25 times 5, all divided by 14, which is going to be 21. That's the expectation value. We can go ahead and now calculate the variance, that delta j, for each guy, which is going to be the j minus the expectation value of j. So 14 minus 21 is just -7. 15 minus 21 is -6. 16 minus 21 is -5. 22 minus 21 is 1. 24 minus 21 is 3. 25 minus 21 is 4. That takes care of the variance. Now we can really easily calculate the squared expectation value. It's just 21 squared, so 441. Now the expectation value of j squared, which is going to be sum over j squared n of j divided by n. So we have pretty much the same thing except all the j's are squared. So 14 squared plus 15 squared plus 16 squared times 3 plus 22 squared times 2 plus 24 squared times 2 plus 25 squared times 5. Right. That comes out to be 6,434 14ths. Not a nice fraction. I'll just reduce it to 3,217 sevenths. Now we can move on to calculating the standard deviation in one way. That way is given by this equation. It's the expectation value of delta j squared under a square root, right? Which is going to be a square root of a sum of delta j squared times n of j over n. Okay. Just gonna copy this table down so I can look at it some more. Right. Sigma equals square root 1/14 times 7 squared plus 6 squared plus 5 squared times 3 plus 1 squared times 2, which is just 2, plus 3 squared times 2 plus 4 squared times 5. Yeah. That ends up being square root of 260 divided by 14. Also not a nice fraction, which can be reduced to 130 over 7. Cool. And then we're meant to check this result for the standard deviation by using a different method of calculating it, which is taking the square root of the expectation value of j squared minus the squared expectation value of j. Right. For that first term, remember we found 3,217 divided by 7. For the second term, we had 441. Giving them the same denominator, multiplying 441 by 7 will get you 3,087 divided by 7. And then if you subtract that, you'll get 130. So it's good.